So in this observe and explain segment, we're picking up on our prediction where we asked you how high did the car have to be released on the ramp in order to make it through this loop without coming off of the track. And so a lot of you identified what sort of forces and concepts were involved. A lot of you realized that basically the centripetal force was going to be provided by gravity. And so a lot of you concluded that the force of gravity had to be equal to the centripetal force when the car was going in the loop. You also recognized that centripetal force was going to be applied right at the top, and so the thing that was going to be keeping the car in the loop was just going to be solely gravity. So the question is, where does this velocity come from? A lot of you identified conservation of energy, and so the change in height of the car between its place on the release in the ramp and the top of the loop was going to be the thing that provided the kinetic energy for the car. And so basically, after quite a few trials, what we found is that delta H in here is approximately 6.5 centimeters. And so let's just give this a try. We're going to release the car so that the delta H between the center of mass and the top of the loop is about 6.5 centimeters. And as you could hear the car was just barely touching the ramp as it went around the top of the loop. And so in this case, gravity is actually providing most of the centripetal force, or all of the centripetal force, to keep the car in the loop. And so we gave you a few parameters. We said that the car weighed 33 grams, whether that's relevant or not. So given what we've shown you here, the 6.5 centimeter delta H, do your observations match up with your predictions, and does this calculation make sense?